In this video, I'd like to talk about the math question of the day for Wednesday, July 19th, 2023. And with this problem, we have this figure here with given dimensions, and we need to figure out the volume of the figure, and we'll give our answer in terms of pi. In questions like these, finding the volume of different shapes are typically seen in geometry classes. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And with a problem like this, there are a couple different approaches that we can take. One is that we can recognize that this shape here is 1/4 of a cylinder. Since notice that for each of these bases here, that they are 1/4 of a circle, and they will be the same dimensions for each of these. So you can imagine this circle extending all the way around, and same for this base. And what we would form is a cylinder. So if we can find the volume of the corresponding cylinder, we can then just divide that by 4 to find the volume of this figure here. And cylinders are fairly straightforward, since we just need to know the area of the base and then multiply that by the height. So that's one approach. The other approach is to recognize that cylinders or figures like these are very similar to prisms, and in fact their formulas work the same way. For a prism or a cylinder type shape, we take the area of the base and multiply it by the height. So let's write that down. If we want the volume, let's say, of a prism, we will multiply the area of the base by the height of the figure. So if we can figure out the area of the base, we can then just multiply it by its height, or in this case maybe its length along this edge here. Now, the key feature that distinguishes a prism or something like a cylinder is that if we look at its base, we can imagine sliding that all the way along the figure so that it perfectly fills it out, and the other base is the exact same area. And if that's the case, then we can use this formula. We find the area of the base and just multiply it by the length that we would slide that base along so that it reaches the other base. So let's focus on finding the area of this base, and then we can just multiply that by 10. Now, this figure here, this is 1/4 of a circle. And we know the area of a circle is equal to pi, the circle constant, multiplied by the radius of the circle squared. Now, since this is a quarter circle, we are looking for the 1/4 of the area of a circle. So we can just divide all of this formula by 4. And it looks like the radius of the circle, if we imagine filling all of this out as a circle, is equal to 2. It's the distance from that center point to the edge, and you can see in both cases that that radius would be 2. So we can plug in a value of 2 to this formula here, and we would get pi multiplied by 2 squared divided by 4. Well, 2 squared is 4, and 4 divided by 4 is 1, so the area of this base is just pi. And from there, we just multiply by 10, the length or the height of this figure here. So we can say that the volume of our figure is pi, the area of that base, multiplied by its height, which is 10 or 10 meters. And I should mention that since the radius is in meters and we're squaring it, this would actually give us units of meters squared. So in total, we have meters squared multiplied by meters, which gives us cubic meters. And we can write this as 10 pi cubic meters. And we should expect cubic meters since we're dealing with space, the volume of the figure, and volume is in 3 dimensions. And if we want, we could even find an approximation for this, but our answer is asked for in terms of pi. So this right here would be the exact answer and would be our final answer. But like I said, if you do want to approximate this, pi is approximately 3.14. So if we multiply that by 10, we would get approximately 31.4 cubic meters.